Hello everyone. Let me start up by thanking Arrow and Juniper and Mist for inviting me here to speak to you today. And I'm going to be talking about, well, the 10 most efficient ways to improve Wi-Fi, or 10 of the efficient ways you can improve Wi-Fi. Let me just begin by telling you a little bit about myself, and then we will jump into these 10 points that we're going to talk about today. So, my name's Peter MacKenzie. I'm from the UK. I am at MacKenzie Wi-Fi on Twitter. So if you're not, how many people here are on Twitter? Brilliant. How many people follow me on Twitter? So there's plenty of more people who can follow me on Twitter. That's brilliant. You can increase my numbers. If you're not on Twitter and you're part of the Wi-Fi community, then get on Twitter, because that's where all the Wi-Fi community hangs out. You can look at lots of blog articles, people post new happenings in the industry. I would highly recommend it. So there's my Twitter handle. Come on and join in the community on there. I work in the UK with a company called Marquest, where I'm the head of technical operations. I'm also the president of the Wireless LAN Association, which is an independent association of wireless LAN professionals. So again, if you're interested in knowing more about that, have a chat with me over lunch or at the break, and I'm happy to chat to you more about that as well. Now, a lot of people know me for protocol analysis, and this afternoon when we do the demo, I'll show you a few more sort of details on analysing packets. But it's a lot of people don't realise that I actually have a built-in protocol analyzer built into me. That's why I'm so good at it. It's not just, and I thought I would start today with a bit of demonstration of my inbuilt protocol analyzer, if that's okay with you guys. Now, I'm going to need 2 hands for some of this. I wonder if you mind being my microphone stand. Is that okay? Yeah. Perfect. So if you just, perfect, brilliant. Okay, so what we have here is I have a pack of playing cards. Now, this pack of playing cards may look like a normal set of playing cards. In fact, I brought it in the airport as I flew in today. But I'm going to show you them in 1 second. Just let me take them out of the box. So this set of playing cards is actually a set of data packets which are going to be communicated over a network we're going to create in a minute, okay? So I want you to think these as not just playing cards, but data packets. Now, if I show you them, you can see they're all different. It's a regular set of playing cards. The best that Helsinki airport has. Okay. So what we're going to do is, I'll in case I've done something a bit dodgy with them, we'll give them a few cuts, because not everybody always trusts me when I have a pack of playing cards in my hands. I was in Vegas last week as well, so you know. I wonder if you just pick one card out for me. It can be any one at all. The importance is you see it, but I don't. Okay, I'll take the microphone back now. So you've picked one card, completely free choice. You know what it is, hopefully. I want you to just hold that close to your chest so I can see it. Perfect. So I'm going to try and use my inbuilt protocol analyzer to analyze exactly what card you picked. But for that, we need to create a little bit of a network. So to do that, I wonder if you would mind just putting your hand on his shoulder for me. And the same. And if we can go around this table, creating a little network. That's beautiful. Absolutely beautiful. So here's a network. Now, all you have to do is transfer, just with the power of your mind, what card you picked all the way around this network, and then I'm going to pick it up with my built-in protocol analyzer here. And hopefully you'll transfer the message correctly. Please know that if this goes wrong, it's not my fault, it's yours. Okay, you're the transmitter, I'm just the receiver. Okay, perfect. So this is how it's going to work. First of all, I want you to do the colour. It's either black or red. I'll help you out there. Okay. So 50-50 chance really with my built-in analyzer first of all. So just think about the colour. Okay, think really hard, and we're going to transfer it across this network. Okay, go. Are you thinking hard? Are you sure you're thinking hard? Because I'm just getting nothing at all. Anybody else get it as it's going round? I'm just seeing blank, just black. Oh, black. I think it's black, okay? I'm going to go with black. That's maybe why I wasn't getting anything. Either that or you've not done this before, have you? No. You have done this before? Perfect, okay. Now, on that card, if it's black, it's going to either be a club or a spade. Okay, so I just want you to think, is it a club or a spade now? Nice and big, club or a spade, transfer it down through our network. Some of you might get an image of this as it transfers through. That's okay. Okay, so club or a spade. Here we go. I am actually getting something. Well done. I think it's a spade. Okay, so I think you've sent me a spade. So now it's going to have either a value on it or it's going to have a jack, queen or king. So I want you to just think about the value on the card, okay? So we think it's a spade. We just need to come up with the value. Okay, here we go. Okay, I don't think it's not too high, I don't think. I'm not getting too much information. Are you guys getting it as it goes by? Yeah. They're all getting it, perfect. You're getting not too high, I hope, yeah? Probably about a 5. I think we're getting about a 5 of spades. Does anybody else get that? They're all not sure now. Okay, do you want to first of all just share what card you got? First of all, is it the 5 of spades? It is the 5 of spades. So, obviously, analysis comes quite naturally to me with my built-in protocol analyzer. And I want to talk a lot today about some of the tools we've got in our toolkit and available to us, which will help us to create efficient and good Wi-Fi. But before we do that, before I get into my 10 reasons, it's really important. The number one reason for poor Wi-Fi is ultimately bad design. And if the design is wrong, we can have all the tools in the world to try and fix Wi-Fi, but we've got to make sure the design is okay first. So let's take this for example, per design. You know, it might meet the customer's requirements as to how many urinals you actually need to get into a room, but I wouldn't like to see them being used at the same time. So design, if our design's wrong, we've got to fix the design first before we try and improve anything else with the wireless network. So if my AP is out in the corridor, I'm already starting off with poor performing Wi-Fi. So let's place access points close to the users. I thought by a bit of a quick way for demonstration. How many people here have heard that you shouldn't put APs in corridors? Yeah? For one reason is it's not close to where the users are. Unless your users are sat in the corridor, why put an access point there? But there's another reason as well, and I just thought I would quickly show you, because a lot of people, it's amazing how many people haven't seen this. We've got some guys from Akahau in here. Here's just a quick map in Akahau. I will throw a Mist AP in the corridor. What a great AP placement that is. Now, every time you place an AP on a map when designing Wi-Fi, you've got to think, what am I placing it there to do? And one of the reasons people like to put APs in corridors is, look, I can get rooms both sides. What a nice, and look at the coverage I can get from it. The problem you get when you put an AP in a corridor is, look at these tails. We have really long tails shooting down corridors. That's what's bad about AP placements in corridors. Why is it bad to have these long tails? Well, what happens if you're a roaming user? You roam down this corridor, and we get to the end of the corridor about where my mouse is, And we all think, and I've got a really good signal. If I go to my little mouse pointer and have a look at my signal there, I've got a neg 51 dB. That's really good, isn't it? That's not going to trigger any roaming thresholds in my client. I'm just going to be connected good. And then I walk around the corner and my signal disappears. So I go to a neg 74. So I go from having a great signal to having no signal within a few seconds. Your machine will then go, oh, I now need to find another AP. It will start going off channel, roaming, and that's when you're going to have per Wi-Fi performance. The same thing if I'm roaming down here. I've got really good signal at this point, a neg 53. I walk around the corner and I lose my signal. That's one reason we don't. Now, if I just place this AP and move it into this room, I've not moved it a lot, but by moving it into a room, I'm still covering the same sort of rooms as I was covering before. But look at my signal. As I walk down this corridor, my signal is going to naturally drop off. When I get to this point, I'll go, oh, I need to find another AP to connect to. And hopefully we've got an additional AP maybe here, that we can pick up its signal and we'll roam from one to the other. And we're getting rid of the long tails spreading down corridors that causes problems. So that is one reason we don't put APs in corridors. So, number one rule, ensure proper AP placement. If our APs are not placed in the right place, whatever else we do isn't going to help. We need to get that fixed first. My second thing is have the right toolkit. A lot of my next points I'm going to talk about are all to do with different tools we can use to analyze a network. Having a good set of tools is really key to being able to monitor a wireless network. For example, having some sort of Wi-Fi scanning tool, whether that if you use a Mac, you've got Wi-Fi Explorer, or there's WiFi if you're on a PC, both two very good Wi-Fi scanners. They're bits of software which can tell me what the wireless environment looks like. I can see very quickly if a customer has placed all their APs on the same channel. I was at a customer not that long ago who was having per Wi-Fi performance, and they wanted a new wireless network because their network was performing really poorly. I went in there to have a look at their system, mainly to specify a new Wi-Fi system, and the first thing I realised when I launched their Wi-Fi scanner, something like WiFi, was that all their APs were on the same channel. This is just WiFi in our environment here, but and we quickly changed that, and suddenly their Wi-Fi performance increased. And the need for spending thousands of pounds on a new Wi-Fi system went away. You can see people using, a lot of the defaults are 160 megahertz wide channels on APs today. Does that work in an enterprise environment? No, it doesn't. With a quick Wi-Fi scanner, we can identify that. So having tools which you can just go to in your toolkit to get a quick assessment of the wireless network enables you to actually fix 50% of the Wi-Fi problems that are probably out there, just by looking at are they using the correct channel widths, are they using the correct channels, what about the minimum data rate that we're using on APs, and I'm going to talk about data rate on another slide. So having the right toolkit is important. My next point is increase the internet pipe. It's amazing how many times I go places and they say the Wi-Fi is really poor. And here's a tool that's really easy to use, some sort of speed test. And I was at a hotel, and everyone said, oh yeah, the Wi-Fi is terrible at this hotel. And I talked to the front desk, and this was, when I did a speed test, this is how much I received, 900 kilobits per second. That Wi-Fi is pretty poor, isn't it? And how many times do we hear the Wi-Fi is slow? When I launched up, this is a little application I wrote for Windows just to monitor it's a PowerShell script. I'll show you this in the next slide. I'll break out and show you it. But this is just tells me what the connection is like. When I looked at my connection, my signal strength, when I was getting that data rate, was minus 56 dBm. Good signal strength? So it wasn't that the Wi-Fi signals per. Look at the data rate, I was getting 173 megabits per second. Good data rate? The Wi-Fi was good. By quickly assessing the Wi-Fi, which we can either do with its PowerShell script, or again, if you're on Mac, there's Wi-Fi Signal, which is a great utility which can tell you the same sort of statistics. My Wi-Fi signal was good. The problem was, what was the problem? Problem was it was going down a very small internet connection. And the hotel only had a very small connection to the internet. And therefore it didn't matter how great the Wi-Fi connection is, if you're going down a tiny pipe, the performance is poor. So one thing we've got to do is when we're looking at the back-end system, a tiny pipe can make really good Wi-Fi suck. And do you know a really big pipe to the internet can make bad Wi-Fi actually seem okay? It's incredibly important to make sure we dimension the pipe to the internet to make sure it actually can handle the connections that are being put down it. Incredibly important. My next point, monitor client behavior. We can create really good AP placements. We can have a really big pipe to the internet. We can make sure that when we do our validation survey, we've got good signal everywhere. We've got our channels tuned. We've got, I don't know, maybe 10 gig internet handoff. But the clients, we still need to know how they perform on the network. And having some way of monitoring a client is really important. As I mentioned, this is a little application I wrote, and let me quickly show you it. It's just a PowerShell script, and it's anyone can, on my website, which is mackenziewifi.com, there's links to download it. And it just sits and monitors your current Wi-Fi connection. So, and you can log that out. This is really useful if you're trying to monitor how a client behaves in your network. Because you can see which AP I'm currently connected to, what signal strength, what data rate we're getting. So we can see here, I've got a really good data rate, and that's because the AP here is on a 5 gig, 80 megahertz wide channel. But it can let me see what's happening. Now, why is that useful? Well, I was looking at some, and this story might be familiar to some of you. This was a hospital, and they had what they call COWs, computer on wheels, which are computers they push around the hospital. They do those for, they push them around the wards, and they can dispense medicine from them. And when I went to this particular ward, I was there because they were getting lots and lots of complaints that the Wi-Fi wasn't working very well. And as I walked around the ward with one of the ward's clerks, they said, oh yeah, here, and we literally stood in a spot, and they said, this is a really bad, we get no connection here. We have all these black spots around the ward where there isn't any Wi-Fi connection. And we were stood in a location, and I looked up, and what was above my head? An AP. But this was a dead spot with no signal. I pull out my phone, and I'm getting like a neg 48 dB signal, but this is apparently a black spot. So why is this a black spot? Well, this is where we need to monitor their clients. So what we did was I put this little application up on their computer on wheels, and we pushed it around the ward. And they told me that they always walk the ward in the same way. They always start at one side of the ward and they push the trolley around the ward. So we put this little application, and I was watching, and I've got a little roaming log here so I can see every time we roam, and we moved, and the signal strength was dropping, the data rate was dropping off, and we got all the way to this point, and we hadn't roamed once. We were still connected to an AP. We'd passed 5 APs. We were still connected to the AP at the other side of the ward. And we were now on like a neg 81. The data rate was like at 1 meg if we were connected at all. So this wasn't a bad place, but the client didn't roam. So for that client, it was a terrible place if you always start at the other side of the ward. So being able to monitor a client's behaviour is so important if we're going to try and understand what the issues are. And then as I pushed a little bit more and I looked at the Wi-Fi card, because the first thing I wanted to do was say, could I change the roaming behaviour? Because you might know a lot of wireless clients, you can modify how aggressively they roam. You can with Intel clients. And I found it was just a little USB plugged into the back of the computer on wheels. A really cheap little Wi-Fi USB. And it had no roaming settings on it at all. And when I chatted to the IT guys about this, apparently when they'd done a proof of concept of the computer on wheels, they all had the built-in Intel wireless NIC cards. It was like built into the screen. These were Lenovo Think Centers, if you've seen them. And they had 10 of them. They did a proof of concept, and they decided to buy 1,000 for the entire hospital. When the purchasing department got hold of that, they was like, oh, if we buy it without the Wi-Fi card and we buy it without this, it's cheaper. So they brought them without the built-in cards. Then they gave them to IT, and IT went, how do we connect them up? There's no Wi-Fi. And they got a quote for Lenovo to basically take the screens off and put the Wi-Fi cards in, and that was really expensive. So the cheaper option was just to buy loads of USB cards, which didn't roam. A lot of USB adapters do not roam. So that money-saving exercise effectively meant that every ward across the entire hospital were experiencing problems thinking that the Wi-Fi didn't work. When the Wi-Fi worked fine, but the clients were not roaming properly. So understanding client behaviour helps us to be able to identify those types of problems and fix those issues as we're seeing them. So having some sort of client monitoring tool. And as I say, there's tools for PCs, there's tools for Macs that are out there. Really important when we're talking about how do we sort of improve in wireless performance. We need to understand the client so we can tune the Wi-Fi or change the client to get better performance. This is a really simple one. If it doesn't move, plug it in. How many people see these things around? They're Wi-Fi printers. And it's amazing how many times people go, yes, we need to wirelessly print, so we've got Wi-Fi turned on the printer. These printers tend to have a little access point built into them. And it's not just printers this, it can be Wi-Fi display systems as well for connecting to printers remotely or Apple TVs. Anything that can act as an AP. And people go, well, we need to wirelessly print, so we've got the Wi-Fi turned on. But the printer doesn't move anywhere. And very often you find that people are using the Wi-Fi anyway to print. I see a lot of these on surveys, and I talk to and I go, oh yeah, you've got a printer with the Wi-Fi enabled, you should really disable that. No, that's in the chief executive's office and they need Wi-Fi printing. They need Wi-Fi printing. So I'm like, okay, so let me understand. It's advertising an SSID called HP Print 8600. Yes, yes. So does your executives, when they're on the Wi-Fi, they connect to the corporate Wi-Fi? Yes, they do. And then they disconnect from the corporate Wi-Fi when they want to print and connect to HP 610. And then they print, and then they disconnect from that, connect to the corporate. And they go, no, they just print from the corporate. And I'm like, so why do you need Wi-Fi on your printer? Let's understand what's happening here. They connect to the corporate network. They send it to print. It goes to an access point wirelessly, over the Ethernet, to a switch, through the Ethernet, plugged into the back of the printer. Yes, that's correct. Wi-Fi printing. Well, then they don't need the Wi-Fi turned on the printer, do they? So things that don't move don't need to have Wi-Fi connectivity. If they plug into the Ethernet, turn off the Wi-Fi and clean up your RF environment. Never bandwidth limit Wi-Fi. This can be a little bit counterintuitive, I think. When I first tell this to people, they go, yeah, but we've got a small internet pipe. We've maybe got 20, some people go, well, we've only got, say, 200 meg internet pipe, and we're a conference facility, and we've got hundreds of users connecting to the Wi-Fi. We don't want one user using up all my bandwidth, so I'm going to bandwidth limit them. And it sort of makes sense. But don't do it. Let me explain why. We never bandwidth limit Wi-Fi. Wi-Fi is a half duplex shared medium. One person goes at one time. Now, we were doing some work for a conference facility which were using bandwidth limiting. They could have up to 10,000 people in one hall. And if you connected to the open SSID, the open network, you were bandwidth limited to 1 meg. It might have even been half a meg. I can't remember. It's quite a severe bandwidth limit. If you paid for Wi-Fi, you could have up to 200 meg. Sounds good, eh? The problem was the people who were paying said the performance is rubbish. Even the free people on the free Wi-Fi said the performance is rubbish. But they said, we're not bothered about the free people, but these people pay and get rubbish performance too. I said, yes, think about it. You've got one AP. They said, yes. Or you've got multiple APs, but in any area, there's one AP advertising 2 SSIDs. Yes, they said. One is the paid for SSID. Yes. No bandwidth limiting. One is the guest one. You've got 100 guests connected to that AP, which you're making go at 1 megabits per second. Yes. And then there's one paid customer who's meant to be getting 200. Yes, they said. Well, it's one person talking at one time. So if I'm that one person who can get 200 megabits per second, I've got to wait for the other 100 people to all transmit really, really slowly before I get to transmit. You effectively slow everyone down to the same speed. It's like cars, isn't it? If you buy a Ferrari, you can go really, really fast. It might be able to go at 300 miles an hour. But if you're driving in rush hour, what speed can you drive? Rush hour speed. Doesn't matter how fast the car can go. If you're queued behind lots of people going really slowly, you will go slowly. If you bandwidth limit people on a Wi-Fi, everyone goes slow. And you have to take it in turns going slowly. In Wi-Fi, we have our most precious resource is time. Time is the thing we have the least of. And if you want to transmit data, I want to get you on and off the Wi-Fi as soon as possible. If you're going to download a Netflix film, oh, I want to bandwidth limit you because you're taking up a lot of room. But no, I'd rather you get on, download the film, get off, and then other people can use the airtime. If I bandwidth limit you and it takes you 2 hours to download that film, you may download it anyway. but now you're contending for access with everyone else for that entire 2-hour period, slowing everyone down. Whereas if you're on and off quickly, within a few minutes, that airtime can be free for everyone else. Now, a good friend of mine, Juniper, if you Google some of his talks he's done on bandwidth limiting, he used to run and manage the wireless network at Denver Airport. And he did some really interesting tests on bandwidth limiting. Go and look them up. But what was interesting, and he had a big 10 gig internet pipe, was that when he bandwidth limited people, he found the pipe was getting saturated. At times, it was peaking to saturation, becoming a bottleneck. When he turned bandwidth limiting off, it never went above about 60% utilization, because he wasn't queuing everyone up. And when you queue everyone up, you're going to get times when everyone together, the peak throughput is more than 10 gig. But if you just let people on and off quickly, they do their stuff, they get off, and they're not all trying to transmit at the same time. Bandwidth limiting is bad over Wi-Fi networks. So don't do it. Okay. Number 7. This is your minimum transmit power in a wireless network should equal whatever the transmit power was in your design. This is probably the thing I fixed the most over the last 2 to 3 years in Wi-Fi, when I go around and see customers. And it's a really simple thing to fix. Let me explain why. A lot of vendors and a lot of Wi-Fi solutions have automatic power and channel settings. Whether we call it RRM or WAM or whatever we want to call it, they have automatic channel and power settings. These can be a good thing. They can be a good thing, especially when you've got a large deployment, maybe 2,000 access points, and you don't want to have to configure the power and channel settings for every single access point. However, you have to tune these settings. If you leave them by default, they can basically change your power from anywhere from normally about 1 milliwatt all the way up to 100 milliwatts. And you don't want that. So we need to make sure that whatever power we've designed to, in our algorithm settings, we set the minimum transmit power to whatever we've designed to, so that the APs can go below that power. And over the last, I reckon, 2 to 3 years, the thing I've done the most when improving people's Wi-Fi is increasing the power. Those algorithms seem to like to tune power too low. Here's an example of a survey I did not that long ago. This was what the 5 gig coverage looked like. And it's not too bad. It still had some holes and we needed to increase the 5 gig. But this is what the 2.4 looked like. And I think the reason the 2.4 looked like this, and I see this an awful lot, is because these algorithms are trying to get rid of something which we call co-channel interference, but they're trying too hard. They try and completely minimize it. So any AP that's on channel 1 can hear any other AP anywhere on channel 1. So I'll keep reducing my power. But from a point of view of a client, it's now got no coverage in most places. Always set a minimum transmit power so that you don't get your coverage ending up looking like this when you're trying to get coverage. So minimum transmit power is, I think, the number one setting when trying to set power levels. And as I say, I always set it to whatever it's been designed to be set to stop problems happening like this. Management overhead. Here is another network I monitored not very long ago. This is a screenshot from OmniPeak Protocol Analyzer, but any sort of scanning tool that can tell you the percentage of frames on the network. Now this was quite a busy network. At the time I monitored it, there was 200, it was a retail store, and there was about 200 barcode scanners in operation at the store at the time. So it was, in terms of, it wasn't just a network with no clients connected, okay? But look at the percentage of beacon frames on this channel. 90.1% of all traffic on that network was beacons. And the further 5% was probe requests. So 95% of all traffic was beacons and probe requests. It doesn't leave a lot of time for my actual data frames, does it? My data frames is this little chunk here. It was down to about 1% of all my packets were data frames on this network. So what was going on this network? Well, first of all, there was 6 SSIDs per radio being advertised in this store. They were actually only using 2, but they had another 4 that nobody quite knew what they were for. Okay, the minimum data rate was 1 megabits per second in 2.4 gig, which means that all beacons were going at 1 megabits per second. So that was the environment. So what we did was purely by turning off the lower data rates and reducing some of the SSIDs, we managed to get that management overhead down to about 8% on the network by turning off 3 of the SSIDs and by changing the minimum data rate from 1 to 12 megabits per second. So make sure we minimize overhead. This is total retransmission rate, and I think even that peak only gets to about 10%, but most of the time there wasn't many retries. So we could look at that and say the RF is actually performing quite well. We have a very low retry count. That is until we looked at the percentage of protocols in the trace. And this was another environment, not quite as bad as the last one I showed you, but most of the traffic was beacons, probe requests, and broadcast traffic. Well, broadcast traffic on a wireless network, is that, do we send acknowledgements to broadcasts? No, we don't. Because if I send a broadcast packet out and I want 100 acknowledgements coming back, what causes a retransmission when I don't receive an ACK? So you're never going to get acknowledgements to broadcasts. If I then, in my protocol analyzer, said, okay, let me just take the data frames, not all the broadcasts, so I get rid of all the data frames and filter just on the data frames and look at retransmissions. Now, this is what my retry counts look like. Completely different. Now my retries are peaking up to 100% of all data frames are being retransmitted. So when we're looking at statistics, we need to know our protocol. We need to know how to interpret the statistics we see, because those statistics are going to help us to be able to identify, is there a problem, is there not? And the amount of time people don't solve problems because they're misinterpreting the statistics they have in front of them. So know your protocol so you can correctly interpret the data you're seeing and understand the protocol. That is me done. Thank you very much.